Okay, check YouTube.
It's live.
Yeah, and so that it gets recorded.
GDC, UCG.
Yeah.
Yeah.
Alright, that's good. Let it just go.
Pretty sure because we can discuss the logo. Do we have yet? Jeremy. Yeah. So you guys make it tonight then? You gotta make it tonight then. On the road then.
Well, yeah, no, that's what I was thinking. Like, why are we so supposed to go? What's this like a
Yeah. I think it should be like.
Does it look good? Uh, should we wait? Actually, I'm going front. Let's go front again. Oh.
Yeah, that's good. But like if something like this fits your front.
Let me make sure that.
Not that. Well, like I said, Steve it's because I got it. Also, I haven't gotten to the I want to get like and that's good. Like, so like, yeah, I'm so good. Let's say you're doing. Let's say you're doing. Sorry, let's start with it's you know. Yes. So these are your answers. I wanted to, but then one junior wrote I mean, it's like, you know, HTML, CSS, JavaScript. No longer, no react. There's one framework. At least back when I started. I think there's less.
All right then. If I could get everyone's attention, please. The GM is now starting, or in this case, the workshop is starting now. Let me just go into a bit of how this works. So the first 30-ish minutes of this will be either a boot camp or a social. And these boot camps are open to public. So next week, we're going to have another one about UI UX. So please come, please bring a friend. After the boot camp, our GDSC meeting will begin. And we would really appreciate it that if you're like a non-GDSC member, if you left after that, just to so it doesn't get too crowded and so the teams can work on their projects. But other than that, thank you all for coming. I really appreciate this. And let's get started on this boot camp, which is called The Art of Starting a Project, which is a system design boot camp by me. So let me present the scenario. Imagine I'm your boss and I just told you guys, hey, you guys have a week to build Twitter from scratch. How would you guys go about doing this without quitting on the spot because you guys aren't allowed to? This is an open floor discussion, by the way, so you guys are welcome to say anything. There are no wrong answers. I'm just going to give you guys a minute to think about how you guys would go about creating Twitter from scratch. Again, there are no wrong answers. Some things to consider are that, how would you track users? How would you show posts? How would you let people post? How would you let images get posted? Does anyone have any thoughts on this? Yeah, in the front, what thoughts do you have?
The users probably have the most motivated all of the users you have, and then each post is associated with this one user, so you have the users, and then users say you got to what kind of aspects you have text, images,
Yeah, no, exactly. You need to have a table of users, you need to know what posts are posting, and you need to make sure the posts are associated. Can anyone think of anything else that they might need to consider for rebuilding Twitter from scratch? Yeah, in the pink shirt there, do you have something? No? How would you let images get posted? How would you allow that to happen? Yeah, go ahead.
I probably want a
server that is just for images, like send it and then send it back to
Yeah, no, exactly. Or yeah, you would need like a separate something to host like images to make sure that the data gets saved there and doesn't like interfere with all the text data. Does anyone have any other idea of how they would rebuild Twitter? All right, that's fine. This was an exercise just to show that rebuilding Twitter is a really hard, it's a really arduous process, and the more you go into the project, the more you realize that, hey, there's this thing I forgot to account for, there's this other thing I have to account for, and that's where system design comes in. It's basically a blueprint that you use to satisfy the user and satisfy the project requirements. And its purpose is to break down a problem, in this case, like rebuilding Twitter, into its components. And you have to create a plan that satisfies the user requirements, that includes the architecture, the components, interfaces, and data flow. So let's go over the overall project cycle. You'll see many iterations of this, but this is my version. The life cycle is basically the idea, the requirements, the design, building it, testing it, iterating upon it, and maintaining it. For this bootcamp, we'll have like special like focus on the first three, which is idea, requirements, and design, since the other three, like the other four are more like when you're actually doing the project. This is more the planning stage of it. Let's start off with ideas. And this stage means that you have to figure out what the user wants. It can be the client or a specific target audience that you want to cater to. Let's say that you want to build a startup with your friend, but you guys have no idea what to build. Your friend comes up to you and he pitches this idea like, hey, I want to build a messaging app. Out of curiosity, how would you guys feel about doing this as a startup? Like just a messaging app. Thumbs up with like you'd be happy to do it. Thumbs down for like you wouldn't be down. Sideways for maybe you'd want a bit more information. Yeah, I'm seeing a lot of thumbs sideways, and that would be my reaction too. It'd be like, okay, and like maybe not that harsh, but it's like messaging apps is such a vague and broad term. Like, look at this. There's iMessage, there's Slack, there's a tech support chat for Xfinity, and there's Snapchat. These all fall under that umbrella. And they all have very different interfaces and they solve very different problems. For example, iMessage, you use that to communicate between your friends. Those messages are saved, they're for like your own reference, and you can create group chats between your friends, but it's like very informal. It's for families and it's for friends. Slack, however, is meant for more professional use. Over there, it's a lot easier to like send files over and also use it on cross platforms, like in both laptops and in mobile phones. And there are specific channels per like workspaces that are meant for a specific purpose. A tech support chat with Xfinity is very different from the other two. That's a smaller component of a larger product. And more importantly, the relationship of the two users that are chatting between each other is different. In a tech support chat, you're trying to solve a problem. And more importantly, you, the user, is trying to get the like assistant to solve your problem for you. And often, like, there are prompts for like the user who has their issue to use, because just so that's like easier for like to have like a script and to figure out what your issue is and to see if like your problem has been encountered before. Snapchat is very different from like the tech support chat. It's like very informal. You're meant to send informal photos, reply to stories, and it's like ephemeral, which means that the text and the stories and the images disappear after one day. So these are all messaging apps is just a very reductive way to think about it. A better way to think about it is that these are all products that were created to solve a problem that a user had. So if you were to go about creating your own problem, or to creating your own project, I would say start off with figuring out what a problem that you care about is, come up with solutions to that problem, and then figure out how to implement that solution to the problem that you have. And I just want to go off on a tangent about AI chatbots. Like in GDC, I've like heard like some ML AI teams be like, oh, like what are some common like ML AI projects that we could do? And like the standard beginner one is creating your own AI chatbot. And I'm not saying that you shouldn't do these types of projects because they're very good for being able to understand like the interfaces, how like ChatGPT works, how LLMs work. But they're basic projects for a reason. These are the types of projects that you use to just like understand a concept and also to make your GitHub look more green. If you're working on a large scale project that you want to show, like put on your resume, you want to talk about it to interviewers, it needs to be grounded in an actual problem that you care about. There needs to be a purpose for you to do it other than just like, hey, I need to do an MLA project. What's a good one to do? Oh, a chatbot. So we've done the idea aspect of it. That brings us to the next part, which is requirements. So you got this idea of a project, right? You got this like solution to a problem. Now you got to break it down into its components to like create clear goals you need to do to like get this idea like going. And these goals can be functional, which means like it's features that your system, your project must have. Like for example, it's like users can create tasks, users can like log in, they can like create posts. And non-functional, which is like qualities that the system should meet, such as like it needs to handle 100 concurrent users. So to come up with these goals, you need to ask questions and then answer those questions yourself. If you're working with a client, you would normally like ask the client these questions to figure out what they're looking for. And for web development, an example of some questions would be like, how many users are using this? What data are we collecting? And how long do we need to keep it? Do we have any third-party services? Do we need to support like real-time updates? There's like chats, live notifications. For machine learning, the questions are a little bit different. It's more like you have a model, right? Like what are the best metrics to evaluate this model? What kind of data do you guys have available? And where are you even getting this data? And is this data being updated? And who exactly is going to be using this model after it's been fully trained? After requirements, you finally get onto design, which is basically the meat and potatoes of this entire bootcamp. This is where you plan for how your system should work. You need to include the high-level architecture. You need to break the system down into its components, including front-end, back-end, and your database. You also need to consider the lower-level details, like your database schema and your API endpoints. An API endpoint, for those who don't know, is a URL that like acts as a point of contact between a client and a server. For example, like if you want to get a list of users, it would be like /users at the end of the URL. You also need to figure out. Okay, so the battery just died, but can everyone still hear me? Okay, great. You also need to figure out the lower level details and you need to define the data flow, which is how the data moves between the different components of the design. Also, you need to plan your APIs and user interfaces. Like how is this user exactly going to interact with the system that you create? Here's an example of a system design of Twitter that's something. For context, if you're in GDSC, we do kind of expect something like this. It will not be as complicated because hopefully your projects will not be as complicated as like redesigning Twitter unless you're really ambitious. So, like, but still, this is something that they expect on your timeline delivery. So you see here, it depicts different services and components like user services, graph services, tweet processing. These graph, by the way, graph services show the relationship between things, like the relationship between users and topics, stuff like that, in case people don't know. It also includes backend databases like MySQL queue. It's Sandy and Redis. That's over there, yeah. It also includes data pipelines like Kafka and Apache Spark. These arrows, these are the things that indicate how the data and requests flow between services, and it shows how the data is processed, how it's stored, and how it's retrieved, and how it's retrieved. So let's talk about the data layers of the data services. So databases like, thank you, Manoj. Databases like MySQL, Redis, and Cassandra, they're all used to store user, graph, and tweet data. These are all things that, if you remember, we discussed at the start, like what we needed to redesign Twitter. Then, what people forgot to mention was that we also need to have something to process real-time events, like notifications, like profile updates. And for that, they use Kafka and they use Spark. Then we move on to the application layer, where services like the user service, the graph service, and the timeline service, they handle the core business logic, which shows how a system, Twitter in this case, fulfills its intended use. Again, this is a high-level flow. It shows how the user would navigate through the entire system. It's a good overview for like your project, for not just your team, but for everyone else involved. Like if you're showing a project manager or like your overall manager or your client, like what you plan to do, it's really good to show them. And like I said before, if you're in GDC, you should have something like this in your timeline. It does not have to be as complex, but like still, you should include everything that you think your project would need to be functional. I'm going to go on a tangent on UML diagrams. So UML is called the Unified Modeling Language. It's universally adopted and recognized, and it's just a method that's used to standardize and just clearly communicate the design of the system. The first one that I want to go over, by the way, there are a lot, but I'm just going to go over 3 that I think are the most necessary. The first one is the class diagram, which just shows the static structure of a system. It shows like the attributes and the methods and the relationships between them. It's really good for object-oriented programming. The key elements of that is that the classes are represented as rectangles. It's divided into three sections. The top section is the class name. The middle section is the attributes, and the bottom section is the method. The next one I want to go over is sequence diagram. This shows the interaction between objects in like a specific scenario. It shows like the sequence of messages that like are exchanged over time. For this, it's not as static. It actually focuses on the dynamic behavior and the time order of events. In this case, this is a system that like looks at a face, takes a photo of them, and like creates a playlist based on their mood. And someone made this. It shows how the sequence diagram would be made. The last one I want to go over is the use case diagram. This is really good for functional requirements, especially from the user's perspective. It basically answers the questions like, hey, what should the system do, rather than answering a question like, hey, how should the system do this? Again, this shows the interaction between actors, which are users or external systems, and the actual system that you're building. To summarize everything, these UML diagrams are meant to help you and your team to understand your project. Not all of them will be applicable to your project, and just like I would recommend like looking through them and seeing which ones might help you. And if you're in GDC, like these aren't exactly required in your timeline. I would just still recommend like making some just so that you understand how to go about finishing up your project and making sure that you don't end up like lost, you know? So that finishes up the design part of this bootcamp. Let's move on to the build. So build is like finally building your project, like you're actually turning your designs into working code. You need to write code for each component, the back end, the front end, the database. You need to integrate them together, and you also need to set up infrastructure for deploying. You'll hear this multiple times. I'm sure you guys have already done this before, but start small and then expand as your project grows. Next one is test, which is making sure that the system works as planned. There are 3 types of testing. There's unit testing, which is testing like individual components, the API endpoints, the functions. There's integration testing, which is when you make sure that the different components that you've created work together. And then there's end-to-end testing, like simulating a real workflow. My personal experience, end-to-end testing is by far the most irritating because you're just doing the same thing over and over again, but just changing like a minute detail because you don't know what could go wrong. After testing, we move on to iterating, which is just improving and refining the system that you've created. This can include optimizing the performance or changing certain aspects to it due to like user testing, and you figure out like another way of doing things is better. The main important point that I want to get across to you guys is the build, test, and iterate pipeline. Systems aren't a one and done process. The build implements the design, test, make sure that it's working, and iterate improves upon the system. Let me give you guys an example of this. Let's say you're building Instagram, but like better or slightly different. You start off with building a component of it. You create your login page. You have your backend to store credentials in your database. You have API to authenticate it and make sure that the right user is logging in. You then move on to test. You unit test to make sure that the login API is working for the right valid credentials. You also do end-to-end tests. You make sure that a user can log in, they can view their posts, and then they can log out whenever they want to. Then you move on to iterate, which is when you show your users like, hey, I finished this, what do you guys think? And after you like let your users test it out, they tell you like, hey, what you've done is great, but like you should implement a feature that's like a forget password option. And you're like, you're right. So then you go back to build and you add that in, and then you test it, and then you show them again, and you iterate upon it if you need to. I won't go into maintain because like that's just making sure that your system still works, like as long as you have it up. Like it's pretty self-explanatory, and it's also like complicated enough that it needs an entirely different bootcamp for it to be useful, so I won't go into it. But here are my closing thoughts for system design. I'm sure there's a lot on your mind that you're thinking, oh my God, use case diagrams, unit testings, user interfaces, system hierarchy, like there's so much to do. Like where do I even begin to like get started on my project? At what point can I like, how much do I have to design until I know that my project will actually work? And that's fair enough. Like it's really scary to get started on something because you're worried that you might get stuck at some point. You're worried that you might not be able to finish it. Let me present the last scenario of the day. Imagine that you're a civil engineer building a bridge. I know, crazy, like no hate to you guys, but like just bear with me and imagine for a second. But yeah, you're building a bridge between two cities. A lot of money was put into this, the stakes are really high, but the timeline is short, and you're given a very limited amount of time to actually plan the design of the bridge out because you need to get like results out instantly. So the design is a little iffy. The physics, they're not completely correct, and you're starting to go over budget, but like the stakeholders, they're getting angry. So it should be fine that you just ignore the design a little and just like cut some corners. So at that point, like what's the worst that's gonna happen? Like who cares if you use aluminum instead of steel for your bridge, right? Like what's gonna happen? Yeah. Whoops, like it's not gonna end well if you cut corners, if you don't design the bridge out properly, if you like, again, if you just don't plan things out all the way, if you're building something physical, if you're a civil engineer. The good news is that we're not civil engineers. Code breaking down is not the same thing as a bridge falling apart. If we want to change something to our system, it's really easy to go back, or it's not easy, but it's still easier to go in there and change something rather than having an entire bridge out there and then realizing that, oh, shoot, at the start, we forgot to do something and we need to add that change right now. And to be honest, planning out every last detail at the start is actually pretty bad for like software development because chances are there's no way that you follow your design all the way to the end. Something is always bound to change. The requirements are always going to change. Software is meant to be malleable, so you should not actively be planning every last instance of it out. The true art of starting a project is balancing it. you can sit there and you can like research every last like third-party service you need. You can figure out the best database for your project, and guaranteed your final project will still be different from everything you planned out. Software, again, it's meant to be malleable. You should not be a slave to your design. It's a tool that's meant to help you understand your own project and to get started. You should be designing your system just enough that you understand the basic components that you need, just enough that you know how to get started, and then you need to get into it. You should just start coding. And along the way, as you encounter more things, as you encounter more milestones, you can create more detailed diagrams and more detailed designs and implement those. But it's basically a cycle, and you should not be stuck with just planning out the project. That said, that was a workshop. Thank you guys for listening. Please love the feedback. And now, like, if you're not a member of GDSC, if you could like head out, we would appreciate that. And now, if you are a part of GDSC, you can start meeting with your teams and get those started. Thank you.
I bet.